Hi students, welcome back. Let's continue with our subject theory of computations. So in the previous video I explained about how to convert NFA to DFA. If there is a non-deterministic finite automata, we can convert into the deterministic finite automata. Now in this video I want to explain you the equivalence of two finite automata. So if you take any two finite automata, whether it may be a deterministic or non-deterministic, if you take any two finite automata, is those two finite automata are equivalent or not, that we need to be checked. Okay, so let's take, suppose A is one set and B is another set. We need to check these two finite automatas are equivalent or not equivalent. Okay, so for that you need to follow some steps. Based on the steps we are going to find out those automata are equivalent or not. So the steps to identify the equivalence are, for any pair of states Qi and Qj, let's take any pair of states, a Qi and Qj. The transition input A belongs to sigma, means whatever the input that we are taking, that is the input alphabets, either it is A, B, C, whatever, that input, either A or B or C or D, any input that belongs to sigma is defined by Qa and Qb, where the transition function of that state, comma, input alphabet A is equal to Qa, and the transition function of the another state Qj, comma, A that belongs to the Qb, then we say these two automatas are not equivalent, because you are getting, whenever the input of one transition is Qa and the input of same input of another transition is Qb, so here if you didn't get the same state, okay, then these two automatas, that is Qi and Qj states automata, are not equivalent if for a pair of Qa Qb. So one is intermediate state and other is a final state. So why how I can conformably say it is not equivalent? Because one if two automatas are equivalent means the both states, that whatever that after transition function you will get one state, a new state. So if that state, if both the rows having the same states, then you can say it is an equivalent. Or if it reaches the final state, both are reaching the final states or both are reaching the intermediate states, then you can say those two states are equivalent. Okay, so don't confuse. If I explain with an example, then you will clearly understand. But the concept here is, whatever the state that you are taken, so in that state, for a particular input, if you get a new state, that is a transition function, if you are getting the new state, if these two states are equal, okay, or if those states are forming a pair of Qa Qb, suppose if one is intermediate and another is a final, then you can say it is a non-equivalent. If both are final, then it is an equivalent state. If both are the initial states, then it is an equivalent. So either you can get both initial and final states or both intermediate state. If one is a final and another is a intermediate, then it will be failed. Or one is initial and another is intermediate, then it will be failed. Those states, those automatas are not equivalent. If one is initial or final and another is the intermediate, then those two automatas are not equivalent. So if initial state is final state of one automata, then in second automata also initial state must be the final state for them to be equivalent. So let me take this example so that you can clearly understand. So here I have taken two finite automatas, A and B. Okay, so here I taken two automatas, A and B. So now I am checking whether these two are equivalent or not. When you say these two automatas are equivalent, when you get a pair of state, if both pair of state, if pair of state both are holding the final state, or if both are holding the final state or intermediate state, both are holding the final state or intermediate state, then you can say those are equivalent. If one is a final, if another is a intermediate, means then the two automatas are not equivalent. So let me explain you with this example. Let me take the states. And what are the inputs for these two automatas? C and D are the inputs. Okay. So first let's take the initial in automata A and the automata B, finite automata. Here having the initial state and the final state Q1, and here also initial state and the final state is Q4. Okay. So here the both are the same initial and the same final. So then you can say for this particular two states, the given automata is an equivalent only to that particular. So we need to check for all the pair of states. If all the pair of states are having both or the same states, then we can say that finite automata is an equivalent. So let me check. First I have taken the pair of Q1 comma Q4. Q1 and the Q4. Okay. So on input C, Q1 goes to Q1. And on input C, the Q4 goes to Q4. Okay, I have taken the initial and the final states. The first one and here the first one in this automata. And on input D, Q1 on D goes to Q2 and Q4 on D goes to Q5. So here what do you understand? The Q1 is the initial state as well as the final state, and Q4 is the initial state as the final state, and Q2 is the intermediate state and Q5 is the intermediate state. Q2 and Q5 are the intermediate state. Means both the states are either the final state or the intermediate state. So then you can say the Q1 and Q4 are these two states are forming the finite automata that are equivalent. So these two are confirming that they are in the correct position, means they are saying that two automatas are equivalent. So let me check with another pair. So this time I will take this pair and this pair, the Q2 and Q5. So Q2 on C goes to Q3 and Q5 on C goes to Q6. Now coming on D, Q2 on D. Okay, Q2 on D goes to Q1, so which is the final state, and Q5 on D goes to Q4. So this is also a final state. So here Q3 is the intermediate state and Q6 are the intermediate state, and Q1 is the final state and Q4 is the final state. So by seeing this, you can clearly say these two states are also these two states are equivalent, which are producing the same the final states or the intermediate state. So these are also forming helping in that the two automatas are equivalent. Now let me take the another pair. So this time I am taking Q3 and Q6. Q3, Q6. So Q3 on C goes to Q2. Q6 on C goes to Q7. Okay, now coming to D. Q3 on D go to Q3 itself, and Q6 on D goes to Q6 itself. So here what do you understand? Q2 is the intermediate state and Q7 is the intermediate state. Q3 is the intermediate state and Q6 is also intermediate state. So both the states are forming either final states or the intermediate state. So then it is also saying that the given two automatas are equivalent. Next, what state I need to be considered? So here the remaining one is here is a Q7, but here no more state is there. So now you need to check. Q3, Q6 is already form a new state. So here Q2, Q7 is the remaining one which doesn't form any new state. So let's take Q2 and Q7 this time. So now Q2 on C. Q2 on C goes to here. I taken Q2 and Q7. Q2 on C goes to Q3 and Q7 on C goes to Q6. Now Q2 on D goes to Q1, which is the final state, and Q7 on D goes to Q4, which is also final state. So from these two states, what do you understand? This is an intermediate state, Q6 is an intermediate state, Q1 is a final state and Q4 is a final state. Okay, now I reached all the states, and all the states are saying the pair of states that are coming from the transition function, those are either the final states or the intermediate states. Not if one is final and if another is intermediate, then you can say the given automata are not equivalent. But here in this case, all the pairs either forming the final states or forming the intermediate states, then you can say this A and B are equivalent. So that condition you have to be remember. The main thing to find whether the two automatas are equivalent or not, you need to check the transition function that you are getting a new pair is both pairs are forming the equal same set of, means either the final state or either the intermediate state it has to form. Then we can say it is a equivalent finite automatas. The two automatas are equivalent finite automatas. So in the next video, I'll take one more examples which violates this condition. Thank you.